So we're going to go into chapter 3.3.1, but back on page 12 in your books, we went over some properties of exponents, which is what we're going to get a little more deeply into. And I think most of this you learned in algebra anyway. Like if we have, say, x squared, it's x times x, right? You know what x to the fourth is. But if I multiply, x squared times x to the fourth, what do I effectively do with those exponents?
Add them.
Add them up, right? Okay. But so that's a power times a power, right? But if I go down here and I have a power to a power, right? I'm effectively doing what with those exponents?
Multiplying.
Yep. Now if I'm dividing down here, right? What do I do with the exponents? Oh, thanks. Whose was that? Oh, I got you. So what am I doing with the exponents here when I divide?
Subtract.
Subtracting them, right? Now here's something that sometimes gets kids mixed up here. In this bottom situation, I subtracted the 2 minus 5, and I got -3. Now, just remember, a negative exponent does not make anything negative, okay? A negative exponent just means the reciprocal, right? So you notice that negative exponent, you put the x on the bottom and it becomes positive, right? Or if it was negative on the bottom, you'd flip it up to the top and it becomes positive, okay? So negative exponents don't make anything negative, okay? They just intend to mean the reciprocal, and then the exponent becomes positive. So hopefully you understand that. Let me pause this, and I'm going to go share the other screen now. So we're going to go to 3.1. So let's get a little more into exponents here. Integer exponents. An integer is just a positive or negative whole number, okay? We're not going to be dealing right now with fractional or what they call rational exponents. And by the way, I don't know if you guys ever noticed, most of these lessons here have a code there you can read with your phone. I guess it takes you to an online video of the lesson. Maybe it's presented slightly differently than I do. I would say any difference in the way I present it is going to be less than optimal, but that's just my hubris, I guess. Okay, so integer exponents. We're not talking about linear functions anymore necessarily, right? So let's take a look at this exercise 1 here. 3 to the -3 power. How could I rewrite that? Remember, it's a negative exponent, so it means reciprocal, right? So what would it be? Maybe flip back to page 12 and see what we did at the bottom there.
We would times it by each one by 3.
No. Well, first of all, let's take care of the negative, right? That's 3 over 1, right? So we need the reciprocal of that. 1 over 3. Now it's positive. You get the idea? And what is 3 to the 3rd power?
1/9.
Or try 27.
1/27, sorry.
3 times 3 is 9 times another 3 is 27, right? Okay. So let's rewrite the next one. 3 to the -2 would actually be 1 over what? 3 to the what?
3 to the 2.
Positive 2, which
3
of
to
course is 1 over
1/9.
9. Okay. What about 3 to the -1? It'd be 1 over
3
to the positive 1, which is just 1/3, right?
to the 3.
Now what about 3 to the 0? Who can tell me what anything to the 0 power is?
Undefined.
Nope.
No, not undefined, but it'll be 0.
Not 0. You're thinking of 3 times the 0. This is 3 to the 0 power. Does anybody remember from algebra? Well, it's 1. Anything to the 0 power is 1. And if we have a minute, if we get some time, maybe I'll explain why that is. But anything to the 0 power is 1. All right, let's just move on then. 3 to the first, of course, is 3. 3 squared is 9, and 3 to the third is what?
27.
27, right? So in each case here, as we went through these integer powers of 3, we just multiplied by 3 every time, right? Makes sense, okay? So here's some rules here. We kind of covered this back in chapter 1, right? So b to the n, right? That's just b times b times b, however many b's, whatever the value of n is, right? B to the 0, right, is what? 1, right?
Anything 1
Anything to the 0 power,
is 1.
right, equals 1. Okay? And then here's with the b to the negative n, right? That's just the reciprocal, 1 over b to the n. Or what if I had 1 over b to the negative n? What's the reciprocal of that? Just move the b up to the top and the 1 to the bottom, right? Just b to the positive n, right? I was going to do it. The 0 power thing. Let's do this. Let me improvise a little bit. Let's go to our notes page real quick. I'll give you an example of why anything to the 0 power is 1. And you've got to think about dividing with exponents. So let's go over here for a second. Okay? 0 power equals 1. Let me give you an example. Let's just take, well, we know what x to the 5th divided by x to the 2nd is, right? What do you do to the exponents?
Subtract them.
So you end up with x to the what?
X to the 3rd.
3rd, right? Okay. Let's try the following. X to the 5th divided by x to the 5th. That becomes x to the what?
To the 4th.
Try again.
X to the 0.
X to the 0. Well, why does that equal 1? Look at, you guys see, any number divided by itself is what?
1.
1. So do you see if you use the subtraction properties and end up with something of the 0 power, you're really taking something and dividing it by itself. Does that make sense? All right, well, let's go back. All right, so there's another exercise down here. So they've given us an exponential function. So not a linear function. How do you know when something is an exponential function? Where do you find the variable?
The X.
Yeah. But where? If it's exponential, the x is found where?
As an exponent.
In the exponent, right? That makes it an exponential function, okay? So f of x equals 20 times 2 to the x, and they want us to evaluate this without using your calculator, right? So we don't need a calculator for this. It's not that hard. So let's do f of 2. That would be 20 times 2 to the 2, right? And you know, order of operation, we're not going to do 20 times 2, are we? What are we going to do first? The 2 squared, right? Which is 4. And what's 20 times 4?
80.
80. Okay? All right, so you guys try these other two on your own, right? Let's do f of 0. And then do f of negative 2. I'll give you a moment to work through that. Let's see how we do. We get something for part B yet?
20.
20. So it's 20 times 2 to the 0, right? But 2 to the 0 is actually just 1. So it's 20 times 1, which of course is just 20. What about f of negative 2? You get that yet? without your calculator?
Five.
Yeah, 5. F of negative 2 is 5. Well, why? So 20 times 2 to the negative, that negative doesn't make anything negative, right? It's really just notation. So it'd be 20, the reciprocal, over 2 to the positive 2, right? Bring it down and make it positive. So F of negative 2 now is 20 over 4, which of course is 5. Anybody have any questions on these? Okay. Let's move over to the next page here. And we're kind of reviewing our exponent properties here, right? In exercise 3, which we did back in chapter 1. So each of the first following, right? The product is a single exponential equation, okay? So in other words, it's going to be written in this form, like b to the a power, right? Single exponent. So you know what to do here when we multiply. What do we do to the exponents?
We add
So it'll be 2 to the
7th.
7th, right? And that's, so they don't want what that is right now. They just want it in that form, that b to the a form I have here. And part B would be 2 to the what?
2 to the 8.
8. And then part C would be 2 to the what?
M plus N.
M plus N, whatever they end up being, right? Simple enough, right? Okay. So let's go down here. Now they're doing the negative integer thing, right? So in exercise 4, we have 2 to the 3rd times 2 to the negative 1. They want us to use the exponent law found in exercise 3C. I guess that was that one up there, right? Right, as a single exponential equation. Well, 2 to the 3rd times 2 to the negative 1 would be 2 to the, we add the exponents, right? 3 plus, notice how I do this, right? I don't put plus minus together. 3 plus negative 1, which would be 2 to the 3 minus 1, which is 2 squared, right?
Hmm.
Okay, which you know is 4, but they just want it as an exponential expression. Now they want us to kind of do it differently, because with a lot of these that you'll see, there's probably several different ways you can start and do things in the middle and finish, right? But they could all be correct. So now they want us to first rewrite 2 to the 3rd and 2 to the negative 1, and then simplifying, right? So 2 to the 3rd times 2 to the negative 1. Well, that negative means it's a reciprocal, right? So it would be 2 to the 3rd what? Actually, let's do it this way. That's why we do it a slightly different look. 2 to the 3rd times 1 over 2 to the 1, right? Wouldn't that be the reciprocal of 2 to the negative 1? Yeah. Okay. What is 2 to the 3rd power, guys?
2 to the 3rd power would be 9. No, 6.
No.
Like, no, 8.
8. 2 times 2 times 2, right? So it'd be 8 times 1/2, right? We know that's 4, but we could also rewrite this like this, right? 8 over 2, which is 4. That's equivalent. Okay, everybody with me? So a different way to go about it, okay, and they're all valid. So let's look at part C. Do your answers from part A and B support the extension of the addition property of exponents to negative powers as well? Well, did they? Did it work? Like when we did it in part A there? Because let's think about it as adding a negative. That's the same as doing what?
Subtracting positive.
Right. So if we're subtracting exponents, it means we're dividing, isn't it? Like in part A, we could think of that. We did it by multiplying and then adding the exponents. But the very same thing in part B, we did it by dividing, didn't we? So I would say, how should we word this? Yes, right? Adding a negative is the same as what? What's adding a negative the same as? Come on. Nobody knows. Well, look up in part A where we added the negative. That was the same as doing what?
The same as subtracting a
Subtracting. Right? The exponents. And when do we subtract exponents? When we're doing what? When do we subtract exponents? When we're doing what?
when we are dividing.
Dividing, right? So we can think of it in a couple of different ways. And they're both valid. Okay? Let's go down to exercise 5 then. So now we have power to a power, right? So I'll write A and B as extended products first, right? I mean, we already kind of know this, but let's just validate what we know. So this 3 squared, it could be anything to the third power. Doesn't that just mean 3 squared times 3 squared times 3 squared, right? To the third power, which is actually 3 to the what?
3 to the 6th.
6th, right? So we took these 2 exponents and effectively multiplied them, right? Because we already did this back in unit 1. 3 to the 4th would be squared. Wouldn't that just be 3 to the 4th times 3 to the 4th, which is really 3 to the what?
3 to the 8th.
3 to the 8th power, okay? And then what about 3 to the m to the n? It'd be 3 to the what? This will be easier just to skip to the last step.
3 to m plus n.
No, power.
M times n.
Yeah, 3 to the mn, right? Okay, you multiply them when you do power to a power. Okay. All right, one more exercise here. Now we're doing kind of the same thing, except we have a negative exponent in there, don't we? So we have 3 to the negative 2 to the 4th power, right? And they want us to show that it's equivalent to 3 to the negative 8, right? By first writing this 3 to the negative 2 in fractional form, right? So how are we going to do that? Let's start out with what they have, 3 to the negative 2, the negative, to the 4th power, right? So that would be effectively what to the 4th power? What does that negative exponent do?
It would become
1
1
over
1 over 3 to the second.
Now it's positive, right? When we flip it, okay? Well, to the 4th power, wouldn't that just be 1 over 3 squared times 1 over 3 squared? Like this. Right? To the 4th power. So that would be 1 over 3 to the what?
One over 3 to the 8th.
3 to the 8th. Okay? But let's write this as not a fraction. 1 over 3 to the positive 8, what would be the reciprocal of that?
3 to the negative.
3 to the negative 8, you know, technically over 1 if we flipped it, right? But that is just 3 to the negative 8. We don't have to write over 1 because everything's over 1. So that makes sense to you? Negative exponents just cause reciprocals to happen and vice versa, okay? So does anybody have any questions on this? It's kind of a review from algebra and stuff we did back in chapter 1. So we're going to have to get real comfortable with exponents, okay? Does a negative exponent make anything negative, kids? Okay. Have any of our negative exponents made anything negative in any of this work?
No.
No, right? Just the reciprocal. And what's anything to the 0 power equal?
1.
1. Okay. So we'll go on to the next list. Let me stop this and save it.